Hey, welcome back. Now, we've just learned how to declare new functions. In this video, we're going to create a function of our own in order to replace some of the code in our program. When we take some of our code in our program and put it in a function and call that function instead, we call this refactoring. You're then going to be challenged to refactor the code involved in updating the animation frame. So then we can reuse that function with both Scarfy and the nebulae. Let's get started. Now here's our program, and just inside the while loop, we're performing a ground check to see if Scarfy is on the ground or not. And to perform the ground check, we have to get scarfydata.pos.y, and we need to check to see if it's greater than or equal to the window dimensions of 1, which is the window height, minus scarfydata.rec.height. Now, we could create a function that can perform this calculation for us and simply return a Boolean, true or false, depending on whether or not Scarfy is on the ground. So we're going to create a function that does this for us. Let's go all the way up to the top, just outside the main function. This is where we can declare new functions. So our function is going to return a Boolean value, so it will have a bool return type, and we're going to call this function isOnGround. Now isOnGround needs to know the position of Scarfy, so we can pass in the animData struct. So our first input parameter will be of type animData. We'll call it data. And isOnGround also needs to know the window height, so it can check the data's position and see if it's on the ground or not. So this will be an integer, and we're going to call this window height. So in our function body, we're going to take data and access the pos.y variable. And we want to see if pos.y is greater than or equal to the value of window height minus the height of Scarfy, which we can get from data.rec. It's going to be data.rec.height. Now this is a Boolean expression. It returns a Boolean value based on the comparison of the values on either side of the greater than or equal to operator. Because this entire line returns a Boolean, we can use this in our return statement using the return keyword. So we're going to say return, and what we're going to return from this function is the value returned by this Boolean expression, which will be true if Scarfy is on the ground and false if Scarfy is in the air. So now we can put this function to use. Let's go all the way back down to where we're performing the ground check. So here we have the if statement, and our condition is the ground check that we're performing. But now we have a function that we can simply call in this if check. So we're going to say isOnGround. And isOnGround is going to take an animData, for which we're going to use Scarfy data. And next we need the window height, and that's going to be our window dimensions of 1, which is the element in our window dimensions array storing the height of our window. Now isOnGround is going to perform the calculation and return the Boolean that we need for our if statement. So we can test this by hitting run and start debugging. And here's our program, and it's behaving correctly. Now we'd like to create a function so that we could refactor the updating of our animation frame. Recall in our code, we're updating the animation frame for Scarfy by taking Scarfy data, and we're changing the value of its running time, accessing the value of its update time, and changing the value of its rec.x. So how can we create a function that does all this for us? Well, we've already seen that functions take their inputs as copies. So let's say we had a function called updateAnimData that takes an animData as its input parameter. Now, if we wanted to change something on that animData, for example, we wanted to set its pos.x equal to 2, we know that this would not work because data, our input parameter, is a copy of whatever we pass in. So say we call updateAnimData with Scarfy data. Scarfy data will remain unchanged, so its pos.x will not be set equal to 2 since it's passed in as a copy. Now what we can do, however, is make a function that has a return type of animData instead of void. And then we can take the animData input parameter data, and then we can change that copy and return that copy as a return value. So instead, we can take Scarfy data, pass it in to update anim data, and then use the assignment operator to take the return value from update anim data and assign that to our Scarfy data variable, overwriting all of its members. This is how we can update our anim data called Scarfy data using a function that returns an anim data value. So in this case, since we're using the assignment operator on Scarfy data is in fact changed. So we're going to use this concept to create a function for updating the animation frame for Scarfy's anim data. So in summary, we learned about refactoring and how we can use functions to replace some of our code to make it more reusable. And we learned how we can change the value of a variable outside of a function by returning a value and using the assignment operator to take that return value and assign a value to our variable. We're going to do some refactoring in the next video. Stay tuned.